Okay, so today what we will do in
Okay.
Python, uh, up to last class we have completed that object oriented, how to do OOP, object oriented programming using Python. So today we will do something called exception handling. Okay. So in our next two classes, including today we will do exception handling, and in next class we will do file handling. And
Okay, fine.
after that, uh, means up to this we will end up the Python, means this course is basically, it's not course. Okay, this class is basically for Python and OOP. Okay, so Python is vast. You have many different segments in Python. So
Okay.
this class is specifically for doing object oriented programming using Python. So up to file handling we will do in this class. Later we will decide if the others are interested, so we will continue with some other segment. Okay, but what today we will do, we will do exception handling. Okay, and this is a
Okay.
very,
Then this course is completed. Means this topic, whatever is been
yeah,
taken.
Python
Okay.
for OOP will be completed. Okay, uh, so in today's class we will decide exception, we will discuss about exception handling. Now exception handling is basically uh, is uh, is a very popular way of maintain your code. Okay, it's all about to maintain your code. Okay. Mm,
Hmm.
in C++, okay, exception handling, we learned exception handling. In Java we applied exception handling. Now in Python we are going to use this exception handling. Now what is exception handling? But before discussing about exception handling, we have to identify what is called an exception. Okay, so error and exceptions are two different things. Okay, in Java there was a clear difference between error and exception. In Python, although it is quite merged, but still it has some differences. So what exception handling basically tells you to manage your code. Okay, what is our matter of concern when a program is actually running? Think, you
Hmm.
are writing the program for your customer, na? Why we are writing a program? We writing a program, we means our developers write the program code for user, means our client. Okay, so we should write the code or develop the program in such a way that our users experience becomes smooth and nice, so that user returns to me again and again for the future projects. Okay, so
Mm-hmm.
if my code, or if my software, or if my application gives user or bother user uh, in many different ways, then for future projects, will the user or the client consider me? No, I think no. Okay.
Nobody will consider.
Okay, so that's why we think about user. We are very much concerned about the user's experience while running the applications. Now here comes a factor called uh, reliability, reliability, and acceptability. Acceptability. These are all terms from software engineering, quality
Mm-hmm.
assurance. Okay, So reliability, acceptability, then consistency, consistency. Okay, so these are all terms which makes a application good application for user. Okay, now what is called, what you understand by reliability means user can rely on the application, that whatever the application is giving the output, user is for with respect to user's need, it is perfect, and every time, okay, it is giving good output, okay, a good solution to the user. Acha, what is consistency? Consistency means the application is going to give legitimate output to the user every time. Okay, consistent way it is producing the output. Okay, so you can define consistency in that way. So if user find my application uh, reliable and consistent, then naturally the acceptability will increase for the application, na? So
Yes.
to user the application is going to be acceptable. Okay, now when user is getting an acceptable application from the developer, so user will consider the same developer in future projects. Okay, because these are the great terms. Okay, so
Yes.
you understand,
Yes. Yes.
in our daily life also reliability and consistency does not come overnight. Okay, so this is an
Definitely.
aged process, aging process. Okay, so if a user find a developer who is reliable and consistent, then obviously the acceptability of the developer and his application are very much high to the user. Okay, so why I am spending this much of words and this much of time to make you understand what is exception handling, because exception handling deals with these things. Okay, exception handling makes your code
Okay.
reliable, exception handling makes your code consistent, and exception handling means making those two terms, uh, just a minute. Okay, so when reliability and consistency is implemented using exception handling, then naturally the acceptability will be achieved in our application. Okay, so how exception handling makes a program reliable and consistent? Simply think in that way. These are not very much hard to understand. Say suppose there is a ATM counter. Okay, near about you, near your home, there is an ATM counter, but um, you visit that ATM to get some money from it.
Yes. Yes.
First day you visit, you get the money. Okay, next day you visit, you do not get the money. Then
Correct.
next day you visit, you your card gets stuck inside the machine, and it took a long time to get rid of that situation. Okay, next day you do not get money, next day you are again getting money. Okay, but there is another ATM counter which is apparently far from your home, okay, than this. Okay, but each time you visit that ATM, you got money without any hazard. Then which ATM will you prefer mostly?
Which is working fine.
Yeah, obviously, because it is not it is unpredictable, it becomes unpredictable. The machine is quite old. Okay, so most of the time the card stuck inside the ATM machine, and you have to do lots of things by calling the security and the bank officials to bring your card back. Okay, sometimes money doesn't come out of the due to some blockage inside the machine. So you will prefer do not go to that ATM. Why I'm giving this example? Because I have such kind of a ATM machine near my house. Okay, so
Okay.
I means I do not like that ATM, and very rarely I went there. If there is no other, I prefer I do not go that ATM. Rather, I go some other bank safety ATM beside that. Okay,
Correct.
suppose I have this ATM of SBI. Okay, so I do not go that ATM, but rather I go to the HDFC ATM just beside that. Okay,
Generally, Canara Bank and
so
HDFC, lots of difference.
yes. So this is the reliability. Okay. So this ATM counter has no reliability to me. Okay, to its customer. Okay. So people will not prefer to this ATM. So this is the case. Okay. So why reliability is very less because during the transaction you cannot expect that the transaction will complete. Okay, the transaction may be exit in between from any place. Okay, so this should not take place in an application. Okay, if there is an error, if there is any mistake, if there is anything, then that should be handled properly with a good type of information giving to the customer that due to this reason I am unable to process your transaction, so please excuse me. Okay, so to increase the reliability or increase the user interaction in a good manner, that kind of behavior need to be implemented inside the application. Okay, and how can we do that thing? We can do that thing using just simple if else. But in case of object oriented programming we have some other option. Okay, uh, that is called exception handling. Okay, so exception it's not like that. Okay, we need exception handling, we must need exception handling in our program. No, it's not like that. Whatever you can do with exception handling, you can do it with simple if else by checking conditions and everything. Okay, but exception handling is an object oriented approach of handling some unwanted situation in your code. Okay, now next, coming to the point, see here, what is error and what is exception. So this is basically error means basically syntax error. Okay, so you are using say a print command, and you forget to put the semicolon, sorry, you forget to put the quotation marks, or the parenthesis closing parenthesis is not given. So these kind of things are usually called errors.
Errors.
Okay,
Correct.
so this is basically syntax error. So error is something like that. Okay, now exceptions are different thing. I usually make people understand in that way exception. So suppose you are walking all along to a road. Okay, now you are expecting, since this is a road, so smooth walking, you should expect smooth walking to the road. Now suppose you have a very big hole inside that road. Okay, so what you will do coming means when you are in front of that big hole on the road, what you will do? Will you try to cross it? Say it is so
No.
big that you cannot cover it using a single footstep. Okay, maybe you have to jump quite long. Okay, so what you will prefer? Okay, so you will find some different things to
Alternatives to
or
cross that.
alternatives. You should find some alternatives. So see here, naturally this hole should not be there in between the road. Na?
Yes.
The road should be smooth so that you can walk all along it. So having a hole here is an exception. Okay,
Correct. Correct.
so exception has a clear difference from errors. This is not an error, this is an exception. Exception means some abnormal programming situation in coding, obviously, but in general terms, exception is some abnormal condition that should not
Yes.
be take place, but unfortunately we are in front of that situation. Okay, so that is an exception. So what you will do when there is an exception, when there is an abnormal condition, that is called exception handling. You got it? Now suppose
Okay.
you decided to give a jump. You decided to give a jump, and as I told you that this hole is quite big. Okay, and unfortunately you are not able to cover up the whole distance. Then what you will do? Means what will happen? You will be hurted. Okay, so that injury means an error occurred. When you are not able to handle the exception, that time that falls under an error. You got it? So
Yes.
exception is any abnormal situation. Okay, if you handle it, then it's okay. If you do not handle it, then there will be an error. Okay,
Yes.
so in that way you can also think. So errors is something like that, that kind of syntax errors and those all, say indentation error. There are different types of errors. Although in Python, exception names are named as error also. Okay, in Python, exceptions are some problems. Okay, during the runtime of the program. Okay, see here, exceptions are generally caused by external factors that program cannot control. Suppose you are going to input some value from the user. Okay, now user have a constraint. You have a constraint to on that value entered by the user. But what happened if user do not maintain that constraint? So that kind of a situation you can treat as an abnormal condition in your program. So that is called an exception. Okay. So exception is something that is caused by some external entities, mostly from user or some operations done by some other factors. Like that, value error. As I told you, suppose you have a variable which is going to take some integer value or number, but you are giving a string. Okay, so this string value for this variable is not valid for your program, hence there is an exception. Okay,
Hmm.
so that exception can be termed as value error. So there are type errors. These are the different system defined exception class name in Python. Okay, so from the names you can find that type error, file not found error means if you are trying to open a file and if the file is not present, then this kind of exception may occur. Zero division error, that is the famous arithmetic exception we handled in Java. You remember? So dividing zero becomes undefined. So that
And
can be
define.
handled by zero division error. So these are different. There are plenty. There are many system defined exception class in Python. So few of them we will discuss, but there is a list you can get it from any web resource. Okay. So this is
Okay.
basically a difference between the error and the exception. Okay. In Python, the difference is very narrow between errors and exception. Okay. Now we have something called types of errors. Okay. Basically, everything in Python in this sense are called errors. Okay. So errors are two types: syntax error and the other one is the exception. So syntax error, you understand what is syntax error, and exception we will discuss about the exception. See here, these are the syntax error. Okay, say in this we need this parenthesis now.
Correct.
This is syntax error. It is clearly saying that it is syntax error. So it is a kind of error occurred during coding, also known as parsing error. Parsing error means what? Means when you
Data
run this
type.
code, so Python interpreter, it is actually called parser, okay, will try to understand what is written here, and it will produce the executable code as according to this. Okay, so there is uh, rules and regulation for this parser. Parser means to convert, a converter or a translator, you can say, okay, which will translate the high level code to the respective lower level codes. Okay, so parser need to maintain the rules and regulations, especially the syntax. Okay, so if it find any mismatch in syntax, so it will raise error like this. Okay, here again there is an error, syntax error, invalid syntax. So while true print hello world, so this thing is not given, na? This colon. So these are the types of error comes under syntax error. Next, exception. We will discuss exception here. See here, although we are trying to define here 10 by 0. So dividing anything dividing 0 is not defined, na? So it is raising
Hmm.
this exception, zero division exception. Got it? Next, we have 4 plus spam into 3. Now, what is spam? Spam has not been defined before this execution. So that's why it has this kind of exception. Name error means this name is not attached to any value. That's why it is giving this kind of exception. So these are exceptions. Okay. So types of exception. Specifically, two types of exceptions are there. One is your built-in exception, means the exception that is given by the language itself. Those are called built-in exception, and the exceptions that user create for their own purpose, those are called user-defined exception. So we have two different kinds of exception. One is your built-in exception, and another is your user-defined
User
exception.
defined.
Okay. So what are the built-in exceptions? There are many built-in exceptions in Python, just like that.
Arithmetic error.
Build, B-U-I-L-T. This will be T. Built-in exception. Say base exception. So base exception is the root exception. Okay. Base exception is the root of all exception. Basically, exception class hierarchy. Okay. Like in Java, you have this kind of hierarchical structure for exception. So the root is your base exception. The root is your base exception class. Okay. So it is the first class, root class for base exception class. And this exception class may be something like that. Okay. So arithmetic exception, arithmetic error is a special type of exception class. Okay. And overflow error, zero division error, these are all a kind of arithmetic error exception. Okay, means these are some child classes of this class. Okay, so this is your the category of built-in exception. Anyway, when we are going to create our own exception, that is user defined exception, we will prefer to extend our class from this exception class and not from this base class. We should not use this base exception class as our root class. Okay, we can use this exception class to define our own exception class or any other class below it we can use,
Okay.
but not base
Hmm.
exception class. Okay. Next, we have user defined exception. Now, what is user defined exception?
which
uh,
can be defined through the programmer.
yeah, as per their need. Okay. Exception should typically be derived from exception class, either directly or indirectly. Now, here indirectly means you can derive your own exception class from some subclass of exception class. Okay. Okay. So next, exception here, the exception classes are, this is a convention, are named as error, means the last you should add a error. So that is a convention. You may follow, you may not follow, may not follow. Okay. Like that, I'm giving an example, the age exception error. Okay. This age exception error is not a system defined exception, as system will not understand uh, about the age criteria. Suppose we are going to build a system, and in that system we have to take the input of human age, or maybe you can say student's age. Okay. uh, in our application. Okay. We have to take input the age. Now, the human age cannot be negative now, so we can check that age value whether it is negative or positive, just by simple writing if else, and that we will do also. But to manage the exceptional situation when user will enter mistakenly a negative value for that age value, for that age variable. Okay. So to manage that situation, in object oriented approach, we have to define a exception class. Okay. And age exception error is something like that. That age exception
Yes,
error, we are
correct.
defining that age
Mm.
exception. Now, how can we define
Mm.
age exception class? There are many ways you can define an age exception class, but
If class,
this class, you know how to define a subclass. This class age exception error, I am giving the name, and we are making subclass of this exception class. This exception class, this age exception error class is now become the subclass of exception class. What is exception class? Exception is the root class, not the ultimate root. It's a root class for all other exceptions. Okay. So inside that
yes,
class, we are not having any code, just passing the, uh, just give the pass keyword. Okay. That means what we do here, we just define a class, a user defined class, age exception error, as a kind of exception, so that system will understand, okay, this is an exception. Okay. Anyway,
okay,
this is user defined exception. We will do lots of thing in user defined, not lots of thing, there is no such scope here, but we will do a code. See here how to handle the exception. Okay. Try, you remember in Java what was
try
there? There
catch.
are five. Okay. Try, catch, finally. Here just three. Try is there,
Right.
except is in
Set.
place of catch, and finally is there. Okay.
Okay. Finally, is as it is.
Finally is as it is, except is the replacement of catch. Okay. So this is your try block. You know what is try block? Try block, or the try clause, is the segment where you have to put your code which you want to execute, and you want to put that execution under a monitor. Okay. Whether there is an exception, whether there is an exceptional situation arise. If the exceptional situation arise, then you perform this operation. Okay. If you do not perform this operation, operation means operation under this except block. Okay. If you do not perform any operation under except block, or if you do not use that try statement. Okay. Now, what is a try statement? This whole thing is a try statement, the whole thing. Okay. If you do not write
Yes.
the code using try statement, then if there is an exception, then the system will
You cannot
terminate the
execute.
program and makes your program unreliable, inconsistent. Okay.
Abnormal terminating.
That is the two term I used in first of my lecture. Okay. So by implementing this try and accept, we process that kind of situation and finish our program or complete our program in such a way that user is not going to um, not going to feel bad. Okay, so here I am going to demonstrate something,
Mm.
this part. Okay, so let's see.
Okay.
So we are taking, ideally we will not write big programs, rather we will write in pieces. Sorry. See, 10 by 2, it will give me 5.0. 10
Yes.
by 0, it is giving me 0 division error. So this is an exception. This is an exception.
It's built in.
It is built in. It is built in exception. Okay. Now, how to handle this thing? Means, if you have some value like that, say a, you are going to input from user. Just a minute. Suppose a and b will be two variable. Okay, you are going to put some
Okay.
value into it, taking from user. So how to write that code? I do not want to write a complete program, that's why I am using this thing as try. See here, a, then there will be b, right? B, and there will be c is equal to a by b. Fine, there will be no problem. Okay, now here we want to print the value. Print c is equal to comma c. Now here you can understand, if user is giving a non-zero value to b, then the result will appear, na?
Yes.
Okay, but if user do not give uh, non-zero value to b,
Non-zero.
user gives a zero value. Okay, let me, write a small code, so that will be better for you. Say this one. Initially I am writing the code in this way. Just save it. exp1.py. Initially I am writing this code in this way. Okay, so what will happen?
Okay.
So run it. Say enter a value. Say I am giving 10 and I am giving b value as 5. We have not converted it to integer, na?
Pass.
Now we will write. Just a minute. Now it's okay. Just save it and run it. I am giving 10 and giving value 5. So it is 2.0. Now again I will run the code. This time I will give a zero value to b. So 10 and I am giving zero. See,
Zero.
our program get terminated by the system. Na? It is saying that zero division error. Okay. Maybe we have several other coding after this. Means we have multiple lines of code here. Suddenly it is the
The
program.
expression terminate. Program terminates.
So this makes program unreliable. Okay, so how to handle it, how to make it so easily? You can do it using if else, but that is a process how we used to handle this kind of situation in non-object oriented programming paradigm. Okay, so we have this exception handling concept in object oriented programming. So since Python also has this facility to identify this zero division error, so we can put this code under try block. So this is the way how you have to write the try block. Okay, which part you need to put under try? So that part from where your exception may arise. So from where your exception may arise. Here is the area from where your exception may arise. Now,
Oh, yes.
only this.
Division part.
Okay. So I have things to say something in this juncture. Letter except. Except. So if I write in this way, if there is an exception, then print there is an exception. Okay, just like that. And you are printing the value of C coming out of this try block. Okay, so just first run this code. Let's see what it is giving. See here. Say enter a value 10, say give 5. So it is giving the result. Okay, there is no problem. Let me adjust the screen. Okay, see here, I am running the code again. Enter a value. This time I am giving 0. See, the name C is not defined. There is an exception, and this exception is not that exception. Okay, this exception,
It is not a division exception.
yeah. Okay, it is not a division exception, it is something else. Okay, now why this is giving? Because name C is not defined. Okay, why name C is not defined? Because this statement has not been executed at all. This statement has not been executed at all. Okay, so what we will do, we will put this code inside this, or you can give a default value to C before. I'm going to modify this code to a extent. See here. So just save this thing. Okay, we can put some message here. Print end of code. So we would like to get this message as an indication that our program maintains the
Is running.
reliability and consistency, that it is exiting just by completing every task. Okay, so if I run this code now, see here, when you give a right value, end of code you are getting printed. Okay, now when you are giving some other value, that means some value that can raise an exception, see here, end of code is also printed
Exception.
and there is an exception. Okay, and there is an exception. So what kind of exception this is? This is a kind of exception that we
Yes.
have not specified here. Okay, so when we write except like that, so in Java there is a difference, okay, from Python. Okay, so in Java you have to specify the type of exception, na? That means the exception class.
Yes.
But here you can specify the except clause in that way. Okay, so it will consider every kind of exception. Whatever exception it will find, it will come inside this except. But if you know what kind of exception it is, as we have come to know that this is the exception, okay, you can write in this way to be more specific. If it is a zero division error, then it will come here. You got it?
Yes.
Okay. So save it and run it. So enter a value, so 10 and 0. So there is an exception, end of code. Okay. So now when you are giving that the zero division error, so you can better say that there is a zero division error. Now, zero
Yes, we can say that.
division exception. Okay. Now, did you understand that if we do not
Yes, I got
mention
it.
that thing, then what will happen? If there is any other exception, then also this statement will be executed. If there is any other exception. Okay.
Yes, it makes more
Now, when you are
reading.
specifying that there except zero division error, so it will come into this place only when there is a zero division exception. Okay. In all other cases, if there is some other exception occurred here, say like that, if I comment this line, so this C will remain undefined. Na? This C will not be defined. Okay.
Yes.
Undefined C you are trying to pin. Okay. So there will be an exception here. But this time, this statement will not be executed. I hope. See, 10, and you can give anything. See here, name error. Name
Yes.
error. So this is also an
Hmm.
exception because C is
But not the one what we defined.
okay. But this, it is an exception, but this is not printed because this exception is not zero division exception. But if you remove this thing, what will happen? I hope this time you can run it. Say, let's see. See, when you remove the class name from here, what is happen? Any exception found here, it has been handled by this except clause, right? So you are getting this zero division exception. So it is better to specify the name of the exception. Now if you want to handle this kind of exception here also, so what you will do, you just write another except clause, because you can have multiple except clause with a try clause.
Okay.
Okay, just like you
Multiple catch
yeah,
notes.
multiple catch you used with a single try. Name error, there is a name exception. Name exception. Okay, now here if you run the code, then perfect match will be found. See, name exception appears. You got it? The concept remains same, just like Java. You have to implement in Python.
Okay. Okay.
So now just remove this hash from here. So we have implemented this thing. Okay, save and run the complete code. See, if you give value like that, then there is no exception. So all the except clause are skipped now. It comes directly here. Okay, but
Hmm.
if there is an exception, if there is an exception, so one of the except clause will be executed and then it will come here. Got it? So
Yes.
this is the way how you can handle exception in Python, and it is quite similar to the other programming language. Okay. Now one more exception may arise when you give some non-integer input here. Okay, some non-integer input, like suppose you are giving 10 here, but you are giving some characters, something like that. Okay, so you are getting some another exception, that is value error exception. Okay, so I told you that you have to put that code inside the try block or the try clause from where you
Which
expect
is
some
causing
exception.
the exception.
Okay, so here we find that these two are such code that some exception we may get. See, so what kind of exception it was? It was a value exception. So you can put another except clause here. So it will be your value error. See, every exception class has the word error. Okay, so it is a convention. There is a value exception. Now this exception has been handled. So if you put some value other than integer, so there is a value exception. So right exception match is been found here, and that part of the except clause is been executed. And if there is any other exception occurred here that is not mentioned in the except chain, so the system will handle it and it will terminate the code. Got it?
Yes.
Okay, fine. Let's move to the presentation. So exception, type of exception, handling exception. Now what is finally? Okay, finally I can demonstrate it straightforward here. What is finally? Finally is a clause where you can put that kind of code which you must execute. Okay, in the context of your program, uh, the code that must be executed irrespective of whether an exception occurred or not, that should be put under the finally block. I am repeating. Suppose you are writing a code, and in that code you have certain piece of line that must be executed whether an exception occurred or not occurred. Then the best area to put those code is the finally block. Finally ensures you, give you the guarantee to execute the codes put inside it. Okay, see here, if I use a finally block, finally is optional, completely optional. You may give finally, you may not give finally, but except is mandatory. Whenever you give a try block, you should have give at least one except block. Although you can give many except block, many except clause, but at least one except clause must be given with the try. Try is incomplete with except. Okay, but finally is optional. You can give finally or may skip finally. Print, inside print I am just printing this message. This is finally. Now see, I will run this code two times. One for non-exception. This is a non-exception run. See here, this is finally. Okay, that means this is executed. Okay, these except
Okay.
clauses are skipped because there is no exception, running this code from no from these lines there is no exception, so all the except clause are skipped, but the finally will be executed. Okay, now I will run another time and I will run another time and give an exceptional value. See here, now there is an exception coming from the division, and there is a zero division exception. That means this except clause is executed. But with that, this is finally. That means this is also executed. So what I am saying, that finally codes under finally clause will be executed whether an exception
However,
occur or not occur. Okay, irrespective of exception, right? So the code
yes.
you put inside that finally block is guaranteed to be executed. Okay. Okay. There are many things with finally. See, I have mentioned some point for try statement. Okay.
Mm.
So how try is executed, what are the things that you can put inside try. So these are some essential points you should remember,
Okay. Mm-hmm.
and every except clause, everything I have already told you. Okay, raise is a keyword in Python which is used to give raise to an exceptional situation. Okay, means
Okay.
using raise, uh, you can raise a new exception. It is specially used to raise the user defined exception. Okay, although you can use
Mm.
the raise keyword to raise system defined exception just like here. Okay, raise name error. Okay, so it will raise this kind of exception, but it is specifically used to raise the system defined except user defined exception. Okay,
Okay.
I will show it to you in the next demonstration. Handling
Fine.
user defined exception. See, this is the user defined exception we handled. Okay,
Mm-hmm.
I will demonstrate this code. Finally, we have discussed, then there is nothing. Okay, let's move to the demonstration part.
Okay.
See, how to raise an exception means you need to raise an exception.
Okay.
Raise an exception in the system, in the runtime. So that can be done by this raise keyword. Raise say name error. Now this name error is a system defined exception class. Okay. So when you run this command like this, system will understand, okay, there is an exception occurred. Okay, although
Mm-hmm.
we have used it with no context, but
It
as soon as
identified.
we put this name, this is an exception class, and we attach this
Yes.
exception class with raise, so system will
Mm.
understand, okay, there is an exception occurred. Okay, you
Okay.
cannot use any kind of class with this raise keyword. You can use only the class which is identified by the system as an exception class. That means a class which comes under the hierarchy of the exception class. Okay, that can be used with
Mm.
raise. Okay, anyway, we will do it, but before that, we will use this raise in our user defined exception handling. Say, I'm creating a new file. say age, I am going to take input. Now, mm, user can give any age input, right? If age is greater than 0, then print age is valid. Else, print age is invalid. Means if age is less than equal to 0, then age is
Hmm.
invalid. So human
Valid.
cannot be negative in that sense.
Ah,
Okay, this is perfectly fine, no problem. Save, run. So if age is 50, age is valid.
valid.
But if I enter age is minus 50, then age is invalid. Okay, so this way we can obviously handle that kind of situation, but this way of handling this type of situation is non-object oriented.
Okay.
So how to handle this kind of situation using object oriented approach? By using some
Who's
exception.
the exception class?
So you can ask me why we need that kind of thing after seeing the code, because you have to write a plenty of things. What we have to do first. So this is going to be our main part. Before that, we are declaring a class age exp, say giving the name age exp, and we are what we will do, we will extending that root class. Although you can inherit from any valid exception class. Okay, so inside this I am just putting no more lines. Okay, we do not need
Hmm.
anything here, although we can put some codes here like the string. You can put a string that will specify the error message. Okay, but we do not
Okay.
need it right now. Okay, so this line tells the interpreter that this age exp is a type of exception, Python exception, and that much we need, nothing else. Okay, now how to implement the thing? See here, if now here we will do try. Inside try, here is the exception, invalid age na. So this is going to be
Yes.
invalid age. So here we will use raise age exp, or this way age exp. Ra- Spelling is okay. Okay, raise age
Ex-
exp. Okay,
exception.
yeah, here I am giving that except age exp. Here I am giving that print statement age is invalid. Okay, so to make things, so I am giving a print statement here. Start is to check the reliability. for consistency, whatever you can say, these two lines must be printed. Systematic start and systematic end more is more
Okay.
required. Okay, systematic end means
Mm.
the program is ending from a single point. Let's run the code. See here, start has been printed. So this line will be executed. Our target is to reach to that line. Okay.
Yes.
So we can say that our program behaves systematically and it is not been
With the
terminated
single point.
normally. Huh. So enter a age. So I am giving some valid age. See here, age is valid and end is printed. Okay. Now I am
Yes.
running the code. Say -5. See here, age is invalid and end is also printed. That means
It is
in
reached to the
valid
end of
or
program.
invalid uh, situation, this end has been printed. Our program behaves systematically. Okay, so user like
Mm.
this. Okay, user will understand. Okay, I have given wrong input. That's why the system is behaving like that, right?
Correct.
So suppose in that ATM, when you put your card, okay, the display is showing that your card is uh, your tape on your card is not readable. There is a scratch. Some
Yes.
message appears, and you take that card and see really there is a scratch on the tape of your card.
Correct.
Then you will be happy. Okay, the system is identifying the problem and it is informing me that okay there is a problem, just go to the bank and change the card. So you will be happy. Okay, the reliability of that system will increase to you and you will visit that ATM, the counter, very often. It's whenever you require because you rely on that system, right? So this way of thinking makes the system reliable and acceptable to the user. And exception handling is the way of doing the thing in object-oriented approach. I am not saying that you cannot do that thing without using try and accept and finally. No, no, no. You can do everything. Just I show you before applying the try and accept here. Okay, you can do it in simple if else.
Yes.
Okay, but using try and accept is a way of doing the thing in
Object
object
oriented.
oriented approach. Okay, now here last question you can ask me, why we need these things. Okay, because we have to write many lines than that thing. Okay, so to say that thing I have to tell many things, but I am just trying to brief the thing. It is because that see, if you are not using this try except, then what you have to do, you have to put this simple if else barely, right?
Everywhere. Yes.
Barely. But this
Yes.
if else, this specifically we need this if else to identify the exceptional situation, right? If we do not want to
Correct.
handle it in object oriented approach. Okay, so see, the if else is such a kind of code block that you will find most often in a big program, big size program, right? So
Mm.
all those if else are required to implement the business logic of your application. Now, this piece of code is not the business logic. This piece of code, okay, this piece of code is not the business logic. It's just a
Yes.
error checking code. Okay,
Yes.
so in a normal approach means handling exception without object oriented approach, there these kind of if else means the if else for error checking will be mixed up with the business logic if else. Now suppose after 6 months or 1 year you have some issues in your program, then you have to find out. Okay, and most often we have watched that the problems comes from these error checking codes. Okay, so you have to find out where the error checking if else are there, and there you have to go inside, you have to dig inside that, and in the way you have made changes some if else which represent some business logic. Then what will happen? There is a
That
clear
may affect
chance
the
of
entire
doing
program.
things uh, means problematic. Okay, so object oriented approach using this try, accept, or try catch makes these things separate, makes the error checking code separate from every other codes. Okay, so carefully, if you, it's not like that you use try and accept and go, okay, my exceptions have been handled. No, no, no. You have to be very careful. What are the codes that you need to put inside a try, and what are the code that you should not put inside the try? You should put only that part of a code from where an exception may occur in future. So you have to be
Mm-hmm.
precise. It's not like that you put everything inside the try, so that will not serve the purpose. Okay,
Okay.
so this is the main thing that you will learn with experience, and with obviously from project experience. Okay, so hope you will
Mm-hmm.
know many things later, but this is the reason why we use exception handling in object oriented approach using try, accept, and etc. Okay.
Finally. Okay.
Okay, baki to you should read the ppt. I have prepared the ppts
Mm-hmm.
from different books, and mostly from
Okay.
this website, python. This one.
Their own original website.
Yeah,
Mm-hmm.
see here you will get beginners guide. You can go here, see here the complete list. See here, errors and
Mm.
exceptions. Okay,
Yes.
so you can read this thing also, but I
Mm.
have taken summarize this part and from some my own experience. Okay, I have prepared those ppts, so you, if you read the
Mm.
ppt, so you will get a idea, quickly get an idea. Okay.
Okay.
Okay, so today up to this. Next day hope we
Mm.
will do the file handling part and complete it.
And then that completes the
Hmm.
thing, right?
The
Okay.
other part. Okay, just let
Okay.
me stop it first.